Sorry, I'm late. So I'm Steve Rich. I'm from the University of Massachusetts. I used to live on Cape Cod for a short time. I've been working for a long time with with the Barnstable County government. Anyone know Larry Dapsis?
Yep.
So I worked closely with Larry, and I was actually one of the people that sort of introduced Larry. So you know, Larry has a background. Larry Dapsis was your county entomologist for several years, and he has a background in cranberry. And so I was one of the ones that sort of got him up to speed on ticks when he first started. And boy, did he get up to speed. If you never met Larry, he is just a force of nature. He's retired now. He went through a pretty rough year, but he's doing fine. I'm happy to report. But anyway, yeah, I
Send a tick to college with Larry.
sorry?
Send a tick to college was Larry's, oh, you don't know about send a tick to college?
Yes,
Yes.
I do. I do know about send a tick to
Best
college.
friends.
Yeah, yeah. So, so we've been out there for a while. I'm joined here today by Melina Ryan, who's a technician that's worked on this project. Anyone know Melina?
No, but hi, Melina.
So how many of you are itch participants? How many of you have had, yeah, so either myself, I recognize from our visit this summer, either myself this summer or Melina in the 2 previous summers were the samplers that were walking in your backyard. So what I want to do today is just tell you a little bit about itch, about how we got to here, why we decided this was a great project and what we think it's about. I want to tell you some results of what we're finding from that study, just a little bit of a provisional thing, and then tell you where I think we're going in direction. And then I always want to leave lots of times for your questions at the end, so I can answer questions you have about ticks or tick-borne biology, tick biology kind of things. So yeah, we come from the University of Massachusetts. We started this center called the New England Center of Excellence in Vector-borne Diseases back in 2022. This was a solicitation from the Centers for Disease Control to build these centers. We are one of 4 centers nationwide now. There's one in the Midwest, there's one in the Southeast, and there's one in the Pacific West. And ours was very specifically, unlike all of these centers were supposed to be targeting vector-borne diseases. So vectors just means mosquitoes and ticks. And ours was quite specifically about ticks because we were the New England Center, and while mosquitoes are a problem in New England, we felt like ticks were an underrepresented thing that needed to be understood better. And so the center does basically 3 things. One is we do operational research, and I always emphasize that the word operational. So the idea is to really try to figure out a way to reduce the number of people that are getting bitten by ticks. And if that sounds very obvious, it should, but it hasn't always been that obvious that people were doing research. A lot of research that was going on was just, in past years, was just towards understanding some aspects of the biology and sort of being able to predict. But what we're focused on is really trying to find ways to make a difference in the number of ticks that are biting people. We're also training, so Melina is an example of that. We're training the next generation of people to work on this. The next generation, like I mentioned before, Larry Dapsis is retired. Someday, not too soon, I'll retire, and we're going to have a next generation of people. So we have people that are training, and I should say the center it's centered in my lab at the University of Massachusetts, but we have satellites in University of New Hampshire, University of Maine, University of Rhode Island, Western Connecticut State University, and Vermont State College, or State University. And training is going on in each of those places. And parallel studies are going on. So not just the project I'm going to tell you about today, although the project I'm going to tell you about today is replicated at each of those sites. So this is a regional project, and Cape Cod is one of the key sites of it. And then the last piece is that we're supposed to be building communities of practice. And that was what the CDC asked for without really defining exactly what they meant by it. So we've sort of had to develop our own definition of what that community of practice is. And that's where I want to start today, is by telling you a little bit how we interpret what it is to build a community of practice around the area of tick control and vector control. So vector control, mosquitoes and ticks, I should say that the older of the 2 is control of control of mosquitoes, because for most of the 20th century, the bigger concern was mosquitoes. Ticks were largely seen as an agricultural problem. They were on cattle and cattle maybe and poultry, and not so much understood to be associated with human disease until 1975, when Lyme disease sort of came about in Old Lyme, Connecticut. But prior to that, everything was focused on, in terms of human disease, on mosquitoes. And as a result, there's infrastructure in mosquito control from that buildup in the 20th century that's not present for tick control. So we don't have the same level of institutional, some of the things we're talking about here, like there are conventional approaches to reduce available habitat or kill vectors directly. Mosquito control district, you have a fantastic mosquito control district here that surveils mosquitoes. Sometimes they do larviciding, they don't do any adulticiding. Elsewhere in the state, there's adulticiding where they actually kill adult mosquitoes to both eliminate nuisances, but also to reduce the incidence of disease. That's mosquitoes. It's typically done by municipal agencies. So in the state of Massachusetts, there's something like, it's been some years since I've looked at the numbers, but it used to be on order of $13 million a year that gets spent on surveillance and control of mosquitoes in the state. That's $13 million more than gets spent on tick control, I can just say. The comparable units don't exist. Sorry?
I was just saying that it just seems so crazy to me, given the incidence of how many people are coming down with Lyme and its associated co-infections. I mean, when you start to study that data, it's impressive data in the wrong direction.
Right.
And so I feel like we are kind of going the wrong direction. And I'm here in North Falmouth, but I'm also in Charlotte, North Carolina.
Mm-hmm.
And there's a thinking like we don't have ticks in Charlotte, but we do have ticks in Charlotte. And our animals are getting in trouble in Charlotte. So this is becoming, I was pleased to hear that you had regional, like United States, taking a look at it.
Yes.
Because of they're migrating and different species, but also because of these co-infections. If you don't know what those are in the areas that you go to, you can't get adequately treated.
Yes.
And so it's a huge deal, and I'm so pleased. We just happened to be here checking on the home and heard you were speaking, and I was like, I gotta go listen to this, because so much of what my journey has been coming down with Lyme here and not getting properly diagnosed in the South.
Yep.
Because we don't have it, that part of it, right?
Yep.
So.
And you're right, it's trending in exactly the wrong direction. It's more and more, not less and less. And it's not just more and more Lyme, it's more and more diseases, as you alluded to, so if people aren't familiar. There's now maybe close to a dozen different things that are transmitted by now 3 species of human biting ticks that are present here. So years and years ago, we would have only saw dog ticks, and then we saw black-legged ticks for the last 45 or 50 years, and now the Lone Star ticks have arrived on Cape Cod. They're quite prevalent on the vineyard. They're not as prevalent on the Cape as they are on the vineyard, but we know that there are tons of them out there. But yeah, so anyway, it's all very much mosquito oriented. All of the institutional support for mosquito control aimed that way. But what we think we can do as a center is we can sort of take a different look at it and come up with maybe some other solutions. And one thing I will say is, I was thinking when I was driving over here, like, remember, I don't know if I've actually ever seen a movie like this, but remember this idea of the cavalry coming to the rescue, like the settlers are in trouble and the cavalry is going to come. The very real and bad news is that there is probably no cavalry coming. So the lack of institutional support, the lack of mosquito control districts is not going to be changed. There's not going to be a tick control district. It's just, for lots of different reasons, I don't think that it scales very well. And so what it means is that it's up to you. It's up to us to come up with solutions to this, with support from the people that know what's, have the best ideas for best practices. But it really is sort of falling onto the hands of residents and property owners to figure that out, large and small. So the way be characterized. Well, so this is the difference between, well, there's a lot of difference between tick biology and mosquito biology. Fundamentally, that mosquitoes have an aquatic phase in their life, so they can be targeted where the water is because that's where they're breeding as juveniles, whereas ticks don't have that same specificity. They also have a much patchier distribution, so they don't aggregate in bodies of water. They can be abundant in one area and not abundant in another, and it can change from season to season and from year to year, and so it's really more of a moving target than mosquitoes are.
How about during the season? I mean, like in July they're over here and in August they're over there, or?
I'm going to show a slide that I think will help answer that question, but there is a seasonality. So one thing you'll hear people say is that ticks are active year-round now. That's true, because as the climate's gotten warmer, we see ticks now in January and February we didn't see before. But there's still very distinct activity periods that I can show you a figure that shows you that in a moment. So this is how we think of this business of communities of practice, and noticing this idea that we have to reconfigure how we're going to approach the problem. And I just use this idea of, these were my terms, but deciders, providers, and guiders in this community of practice. So there are people that are deciding what to do about mitigating tick risk and infection risk associated with. It's a personal decision, both your personal your decision to either do something about ticks that are in your yards or on your property, or to make personal protection measures like the wearing of permethrin-treated clothing or repellents that can protect you individually. Then there's providers, the individuals that actually provide those materials. So I think about Larry Dapsis when he was here, your county entomologist. He used to go and I don't know if browbeat's the right word, but he used to go and insist that local providers have permethrin on their shelves, which is one of the things that you can use to treat your clothing. So he was ensuring that the providers were in abundance and that they were given the materials that people need. And then of course there's the guiders, which are places like, again, Larry Dapsis and the Barnstable County Department of Health and Environment, the extension agencies we think are very important. And I think there might be some other institutions that can sort of be incorporated in that, including possibly libraries, because they're local and they can communicate valuable information and guides that will help people to make decisions about what they want to get from their providers. So our role in this is to sort of make the connections between those different pieces, to make sure that the providers, as it were, if they're providing materials for tick control, that they're providing the right ones, that they're doing it in a manner that's understood, so that we know what the risks are of those things, and that the deciders can make accurate decisions, and that we're making partnerships with the guiders that are actually going to provide that information to all of you. So building a community that way. This is sort of one little example of that kind of thing. So you can imagine deciders being hikers. Someone's going to go for a hike, they're going to make a decision what they're going to do, if anything, to protect themselves against ticks. They've got outdoor sporting goods places where they can get materials that can protect them, including clothing. And then the guiders could be the land managers or the Department of Conservation Resources that can tell them people about what best practices are. So all of that's to say, that's the context in which we thought that Itch was a good place for us to start our center when we inaugurated in 2022. And we thought that one thing worth focusing on was the fact that people were doing backyard sprays to try to reduce the number of ticks in their backyards. So it was my colleague Tom Mather that actually came up with this idea for the project called Itch, Is Tick Control Helping? And we asked that question quite literally to determine how the different methods that people are using to kill ticks in their backyard, how well they're working. I'm going to tell you some of the results of that study in a second. But that study started with a survey that we sent out to, it was on the order of 75,000 people throughout New England. We got about 5,000 or 6,000 respondents, including some of you in the room, where we were just trying to gauge what people knew about ticks and mosquitoes and ticks, tick-borne diseases, so that we understood the baseline of knowledge there. And then from that initial survey, we recruited people to come into this survey. We asked if it was okay to go into your backyard and to sample ticks so that we could set up this experiment where we could look at treated and untreated yards. So tick control, is tick control helping? Project is tick control helping? Initially, it was set up to test whether bifenthrin, which is a common conventional insecticide that's used by companies like Fowler & Son, which is the one that we've been partnering with to identify treated yards on Cape Cod. We wanted to see if that made any difference in terms of the density of ticks in backyards. And I want to be careful when I say, is tick control helping? Bear in mind that we're asking the question about whether it controls the incidence of ticks in backyards. And we should keep in mind that even if it is effective, that may not be the whole story, because if you're keeping ticks out of your backyard, but your neighbors aren't keeping ticks out of their backyard, and you wander over into that place and you get, for a barbecue or something, and you get a tick bite, you don't have the same protection. So the way we set up these studies is very particular. We're just looking at what's happening in people's backyards. And then from that, it sort of grew out in a couple other questions, including the fact that companies like Fowler use natural products, so products that are not synthetic chemicals like bifenthrin. Many people have an aversion to using those kinds of chemistries, and so we wanted to look at whether those natural products were working as well or not as well as the synthetics. And as a corollary to that, and I should emphasize, we're not shilling for any, we're not working for those companies. We're not proposing that people test. We're not encouraging people to test. What we're trying to do is determine whether the spraying is actually having an impact on the ticks in their backyard.
Is Fowler and Son, are they a local?
They are local, yep. They've got, I think, over 1,500 customers on the Cape, so they were a good partner for us because they allowed us to identify properties that had been treated and treated in a way that they could.
But they're not using the insecticides, they're using other, like, oils and
They're using both, and I don't think there's anyone from Fowler here today, but I'll tell you that one of the things that we liked about them that made us think they were honest brokers is that they really wanted to see whether the synthetics were working as well as the natural products, because they used both. And they felt like that.
So when they treat, they actually use both? Wow.
No.
No,
They use one or the other,
Oh, I see,
but
okay.
they use the customer's choice.
I got you.
So some customers don't want to use bifenthrin, then they want to use the natural products. So I'm not going to talk too much about that. I'm going to tell you a little bit about the results we've seen from the bifenthrin study, and all of this that I'm going to tell you about today, I should emphasize, is preliminary. It's not been published or peer-reviewed or any of that. So you're seeing it like as an early, because for those of you that have been participating, it's your data. You helped us to accumulate it, so we wanted to push it back to you. And that's just another example of how this community practice, like the hiker example I gave today, we think each homeowners can be part of this community of practice where we can hopefully advise you on what's working and what's not working so that you can make informed decisions about how you want to take care of your properties and try to reduce the incidence of ticks. So this is just a little more technical details of what we're doing. We're comparing tick counts on treated and untreated yards. So we go into the properties. I'm going to show you how we do that in a minute. And then we compare the conventional synthetic erythroids with natural products. We report results back to homeowners. That's what we're doing today. But we also tell the state and local health agencies, as well as the pesticide control operators. That's companies like Fowler, that we're finding this works and this doesn't work. Maybe you want to consider these sprays. So the kinds of considerations you can go into that are not only what products you're using, so what sprays, what active ingredients are sprayed, but also when they're sprayed. So one way that we think to reduce the incidence of off-target effects, because one of the concerns people have is, they want to kill ticks, but they don't want to kill pollinators and butterflies and other things. So one of the things we think can be done is you can be mindful of the time of year that the sprays are applied. So you apply in the fall when the pollinators and the Lepidoptera are not as active, or you're not as likely to hit those off targets. So we think that may be some benefit, but that needs further investigation as well. So let me tell you just details of how this study was designed. So this was on paper. we imagined that properties would look something like this, that there would be 3 different zones. You know, there's your house, and then there's the part of your yard where you probably spend most of your time, which is like a lawn or maybe a hardscaped area. And then that's what we call that zone A. Then there's zone B, which is outside of that, where maybe there's low shrubs and sort of the edge habitat that interfaces with the deeper zone C. And Melina could tell you, like, it turns out that our image of what an ideal yard looked like, it's like every, you know, like the family with 2.3 kids, you know, it just didn't, we didn't find ideal yards. No one's yard necessarily fit this. We saw all range of different ways that people landscape their properties, including some where everything was basically mulched to places where everything was just allowed sort of to grow freely. And so we were surprised, not surprised, but we learned a lot from how people manage properties. Nonetheless, we sort of adhered to this and we tried to identify where we could. Zone A, sometimes zone A was smaller on some properties and sort of restricted it very close to the house. Other times people had very large yards, and so we sort of incorporated that into the study. But we sampled from each of those different zones, and our expectation was that, yeah, we might see dog ticks here, because I should say that the black-legged tick, the one that causes Lyme disease, generally they don't like manicured lawns. They don't like grass that's been cut. They're very susceptible to drying out. And so on the cut grass, they have no place to basically get out of the sun and keep themselves from drying out. So they tend to be more in this habitat, which is on the edge. And they're not so crazy about this either, because there's not as many white-footed mice, which they feed on as juveniles, or white-tailed deer, which feed on that edge habitat, because that's where the best browse is. So I think this is kind of the sweet spot for zone B in here. And that's primarily where the spray companies go. So if you're getting your backyard treated, this is what they're doing. They're doing a perimeter spray just inside of this zone B. So we sampled zone A, B, and C where it was possible zone C. Not a lot of properties on Cape had zone C. And how did we sample them? We used a flag. If you watched Melina do it, it's just a piece of cloth. We should have brought one.
I have my car.
Do you have one? They're like, what are they, a foot wide, 18 inches wide? By probably 3.5, 4. They're very set of dimensions that neither one of us can remember at the moment, but they're adhered to this wooden dowel, and then Melina or myself, we just drag them across the vegetation, because what ticks are doing, they don't fly, they don't jump, they don't fall from trees. What they do is they quest. And quest just means they crawl up to the top of a branch or a blade of grass. They stick their feet out and they wait for something to, legs out, and they wait for something to jump onto, to grab onto rather. And this flag works as well as anything else. They don't make a distinction between a flag and you or your dog or anything else. So they work quite well as sampling tools. And we use white cloth, and it's got a little bit of a pile to it. But we use white just because it's easier to see the dark ticks against the white background of the flag. And so we drag them around. Actually, I think I have a video to kind of show you, the training video that features Melina. She was being trained and making the training video at the same time at the University of Rhode Island. It's a timed effort, so we do it in 30-second bursts. We sample for 30 seconds, we stop, and then we take off the ticks, count them, and then sample for another 30 seconds. So it's very uniform, the sampling. And theoretically, Melina should be able to do the same sampling that I do. If we sample the same site, theoretically we'd get the same sample. And that's what we're trying to do, is standardize the sampling both on Cape Cod. So we used, last year we had probably 18 AmeriCorps AmeriCorps workers that worked on the project. They each were trained, and each of them used the same methodology. So as much as possible, we tried to make the sampling uniform. So they drag the flags, and then they use forceps to pull the ticks off, and then they go into these tubes, and then go back to the lab where we count them and test them for pathogens. Yeah.
I guess this is a place to nitpick or whatever.
Or tick bait.
Most people, not most, but you're gonna get stuff that ranges from bushes to the size of trees, etc. I thought the idea of using a flag rather than a drag thing was to be able to get up, higher up, but what do you do for a bush?
So you can use a flag as a drag. So the distinction as a drag is like you put it along the ground and that's where the nymphs are. But the flag you can take high or low, as high as you can reach basically. But the ticks tend not to be too high above waist level.
So if you encountered a bush, would you flag it around it, or?
Yes, yes.
Okay.
But that would tend to be more either zone B or zone C.
Mhm.
Yep,
Great, thank you.
you're welcome. It's a good question because, one of the things we quickly realize is like one property might have a series of bushes and then another property doesn't have any bushes like that, or not the same type of bushes. Like some might have small, arborvitaes, and then other ones would have bayberry. So it was hard to make all those comparisons across the area. These are sort of pictures of what zone A looks like. So zone A would be the grass, and then you see where it sort of transitions into zone B, and then zone C, the deeper forest area. So just to round out everything that we do there, we fill out these forms where we characterize the lawn, make note of different characteristics like how many drags we did and the sample labels and all that kind of information.
So what is the typical range of counts per 30-second drag on that white flag?
It could range from 0 to probably high 20s is the most that I ever saw. Did you ever see one?
There was one time I think I got 30s, maybe 40s minutes.
If you heard 30 or 40 ticks in a drag. So we dragged once around the property, so that might have been a larger property. Probably in Falmouth, right?
I can't remember, but I was
Well, I
there for
remember
2
going to a
hours.
particular property in Falmouth that was very ticky, and I talked to you about it, and you said,
Oh, yes,
Yeah.
yes, it was that one, yes it was.
And are these all kinds of ticks?
they're mostly black-legged ticks. So we target the time when the nymphs are most active because we're focusing on them. But we do encounter other species as well, and I'll show you the results of that. So we found Lone Star ticks and dog ticks as well.
So what is the time when the nymphs are most active?
I promised you I'm going to show you that graph. It'll be very clear when I show you. It's basically from late March, early April through June, July, and then it's the second time in the fall.
This tick behavior, once they've staked out their branch or their grass, they're going to go up and hang out at the end of. Do they range? They move very much? I mean, like once it cleared the area with a drag, is that going to repopulate at some point?
That's a great setup question. So yeah, what they do is they can't manage moisture in their bodies. They can't control. They dry out very easily. So dry conditions and hot conditions are detrimental to ticks. It kills them. So what they do is they sort of take a risk going up to the edge of that blade of grass, because if they don't get a blood meal that day, they've used some energy to get up there and they've dried themselves out, and then they got to go back down and they don't recoup that because they never drink water. They don't. Lone Star ticks might take a little bit of water, but most of the black-legged ticks don't ever drink water. So every time they go up that stick, and they don't get on something, they're one day closer to dying. So if you can keep them from getting on something, then you can work against them that way. And we do think that the flagging process itself can be effective at reducing the number of ticks if you do it in often enough. We know that because out at the university, out in our Amherst sites, where we collect ticks all the time to bring them into the laboratory and basically find ways to kill them. So we use them as experiments, and so we go out to our favorite spots and flag as many as we can. And some of we see the diminishing returns on the flagging because we're actually flagging them out. So some thoughts that have arisen as we've done this is that if we could find a way to flag more abundantly, maybe we wouldn't need to use chemistries, that you could just, and contemplating like how we could sell that to people, to you all, as something that you could do. Like you just go out every evening and flag the back 40 and pull the ticks off. It can.
Yeah, I was going to ask, like, can you buy these type of flags that you have to like, check your property, or?
That's where the libraries came in. So I initially had spoken to Centerville, so I was staying in Centerville, and when I walked over to the library, I said, if we had these flags, which I'll show you how they're made in a moment, available to people, could people come to the library and borrow them? And we thought it through a little bit, and they're like, not borrow probably, because they don't want to bring them back.
Yeah.
But we could distribute them through libraries. So if there was like an educational video, which we have, I'll show you in a moment, we could distribute them through libraries as sort of a local sourcing of, if you want a flag, we can get a flag too.
Could an old cotton pillowcase be
Yep.
used?
Yeah, we would ideally like to have this uniform size so that we can collect all the data, but an old pillowcase or a blanket will effectively remove ticks. It just wouldn't be as interesting, wouldn't be as inclusive in our study.
No polyester.
Ah,
Polyester's okay, but they kind of slip on it a little bit.
That's
Flannel.
when something's
Cotton's
sticky.
good. Yeah, flannel.
Is there a time of day that's, like, do they operate 24 hours a day?
Not 24 hours a day. So the animals that they feed on are called crepuscular. So they're not diurnal, they're not nocturnal. Crepuscular means they're active around dawn and around dusk. And that's when the ticks are most active. So the ticks, it's not to say that you won't see ticks at noon, but you'll see more ticks close to dusk or early in the morning. They're playing that game where they're trying not to dry out, they're trying to stay out of the sun, so they pick those times sort of as optimal. We don't sample when it's raining or when there's heavy dew, so we find it's harder to sample, partially because the flags get wet and then they get bogged down, but also because the ticks, in addition to being susceptible to drying out, they also get mold infection. They die from mold infection, so they try to avoid those conditions as well. I have no sympathy for them, I'm just saying. So then the ticks go back, I mentioned, so we collect them, we count them, and then they go back to our lab at UMass and we test them for different pathogens. And this is, we think, a powerful way to remind people of what's going on in their backyard. So if you're an itch participant, show me his hands if you're an itch
you
participant.
what, what's the question?
If you're one of the itch properties, if we sampled your property, if you're not, talk to Melina about how you can get on next year.
Flag it every day.
You do?
I said, if you do,
Oh, great.
you're welcome over.
Excellent. If you're doing it, we can give you the results of the ticks. We can tell you what pathogens are backyard. We can almost tell you without testing them, because we know that almost all the adult ticks have about 50% Borrelia burgdorferi, the thing that causes Lyme disease. About 10 to 12% are anaplasma and babesia, the other two diseases that are associated with black-legged ticks. But we test them
Did you
anyway.
say 10%?
Yes.
Sorry?
I was just so Babesia is about 10%?
It ranges from, it can sometimes be a little higher, but approximately 10%.
Did you say Lyme was 50% and Babesia 50%?
For adult ticks, Lyme's in about 50% of it.
And then the third one?
Babesia and anaplasma.
Are you counting Ehrlichia and Asthmaplasma as one, or are you counting Ehrlichia and Anaplasma?
No, anaplasma, anaplasma was called Ehrlichia, it's now a different species, so.
The reason I'm asking, I'm still recovering from Ehrlichia.
Oh,
Yeah.
where did you get the infection?
Here,
That's pretty rare. 'cause-
not in the library.
Did that answer your question?
I couldn't hear. Could you repeat those ratios again?
I'm just giving you approximate, but about 50% of the black-legged ticks have Borrelia as adults. About 30% of them have Borrelia, Lyme disease pathogen, as nymphs. And then the numbers for the anaplasma and babesia, the co-infections you were alluding to, are on the order of 5 to 10%.
Thank you.
Do you have a website with those stats?
Tickreport.com. I'll say it, tickreport.com publishes tick testing data, and you can type in your zip code, you can type in all sorts of things.
Thank you.
Yeah.
And is there information about the illnesses themselves on these sites?
Symptomatology.
There is on the DPH site, on the Department of Public Health, which you can link through the NUVEC site. Yeah, there's stuff about that. But we focus primarily
That's not your job.
on prevention, yeah. Yep.
What's the public opinion about how long a tick has to be on you before it can infect you?
And that's the kind of question.
So I've been doing talks like this for about 10 years, and I used to come and say the best science is that it takes 24 to 48 hours. And invariably, someone's hand would shoot up and they'd say, I had a tick on me for 6 hours and I had Lyme disease. So I'm not here to tell you anything that is not compatible with your lived experience, but the science is that the average is 48 hours. And that's not to say that it can't happen quicker or later, it's just to say that that's what the distribution was. Yeah.
If I may, I'm an epidemiologist in Barnstable County. We have a new tick website that answers quite a few of the questions of just like what the incidence of disease is in our community. It's capecod.gov/tick prevention. And it has a lot of detail about tick-borne disease too.
It's a great site.
Thank you.
Yeah.
Spent a lot of
I've
time
been
building
on
it, so that's very nice of you to say.
kcog.gov/tick
/tick altogether. Tick prevention.
Was it your website that also had the data on the animals? Because I was Googling and trying to look up like how many animals like in the greater Falmouth area, you know, what was the estimate of how many animals have come down with Lyme? And I believe I read it was like 1 in 6 for dogs. So
Oh,
was
not
it-
my website.
Okay.
But there is like there's a veterinary national website linked on there about just
Great.
testing data.
Great, thank you.
Let me play this little video. I hope it doesn't do the sound, but this video will kind of show you how we make the flags. Yeah. You might hear it, but you don't have to listen to it. This is the training video that Melina made. And this went to all our collaborators. So this is how you make the flags with, we use Velcro.
From the end of the flagpole, begin sticking it down in as straight a lump as possible.
We use Velcro just because we can then take the flag on and off and then wash it to remove brambles and that kind of stuff. It's just a wooden dowel. For the burst that I mentioned before, we use this app that's a, what do you call them, interval? Yeah, interval trainer app. So we set it, it's not really absolutely necessary. You can sort of count it out in your head as well. But this is a way to keep a strict repetition to the bursts of sampling. These are the different habitats. So there's an example like of a habitat A where then it kind of goes into that mulched area, which we didn't really have a configuration for that. Zone B is a little thicker. This will show you how they sample zone A, I think. There's a voiceover to it too, but I don't know. Oh, that's Melina. So to your point before, if there was brush, you would take the flag up higher.
So if you had a place that deer like to eat, you could sweep it every morning theoretically?
Yeah. Yeah. Tom Mather, the guy that came up with this study, he's very good at finding deer beds, because deer, when they lay down, the ticks fall off them, and he finds the deer beds and can pull the ticks out of the grass that way. He also he has a superpower. It's like his only superpower, but he can be walking down a trail and he'll say, there's one, and he'll walk over to a brush, piece of brush, and he'll pull the tick off the bushes.
Are they prone to other animals like rabbits or birds that get in your yard?
Yeah, that happens. Are they, which?
Well, like, would you find them like, you know how there's a lot of rabbits running around from yard to yard and birds? Like, is that a method of spread potentially, or?
The birds help to spread them farther because they, as juveniles, that's larval and nymphal stages, the baby ticks, they mostly feed on white-footed mice. And the white-footed mice don't move very far. So the way they'd get, for example, from one side of the Cape to another, or from one state to another, is probably by getting on a bird and then phonetically being moved around.
Do you know if they are fond of chipmunks?
Yes.
Or is it really nice?
They will feed on chipmunks in abundance as well if they're there, yep. There's the sampling, that's Tom Mather in the middle. And this is the checking, so periodically stopping and then plucking them off, and you can get some idea of the boxes in the way, but you can see how very, very small they are. And then recording the data, which goes back to the laboratory, which was done in each one of the properties. We did 20 in the first year, 175 or so in the second year, and then this past year it was 70 properties that we sampled. So 70 of your yards that we went into and pulled ticks out of. And we filled out these data sheets for each one, and then they go back to the laboratory. That's all detail, so, yeah.
So, have you, sounds like nobody would want you to dump 1,000 ticks in their yard and then do this experiment, but if you know how many ticks are in an area, do you know the relative percentages of larvae, nymphs, and adults that you get with a drag?
Yeah, so we've thought about irradiating them so that you're releasing the ones that wouldn't be able to reproduce, and then you could do that. So you put out 1,000, you come back 3 days later and see how many of the 1,000 you could recover, so as a measure. But as I said, they're so spotty anyway that it's really hard to figure out what's all going on there. So what I want to do here are just a couple slides that sort of report on the first year, first couple of years. This is the one that I showed you before, or not showed you before, but I was mentioning before. So these are actually data for nymphal ticks, so they're a little bit lower than the percentages I gave before. But you get some idea of, for Borrelia burgdorferi, they're actually a little bit on the low side. But the Lyme disease spirochetes are in, so you see from 14 to 22%. Babesia, the other co-infection, somewhere around 10%, slightly lower in the anaplasma. And that's, part of this is like, there were a relatively small number of ticks in 2023. The point is that the 3 pathogens are present in each of the different islands, or each of the different properties. So this, again, is preliminary, but if you look across at the treated and untreated, you can see there's upwards of 10 times more in the untreated property than there's the treated. So it's pretty striking that there's a difference in the treated and untreated properties in the samples that we're doing. Similar study being done at URI, University of Rhode Island, is giving similar results, as well as at UMaine. Yep.
Do they have a way to project, like, so this is a sampling, this is a confined, controlled sample, but what do you extrapolate from that, or can you, as to if this is what we're sampling, what do we really think it might be? Is it some number higher likely?
Or you mean if we find 51 ticks, how many ticks are actually there?
Like when you start taking this data, because your sample is a certain size,
yes.
Correct? And so you're making some thoughts and projections, but does it help you to know, well, if it's here, it really might be here? Do you know what I'm asking? Like, is it really, this was our sample size, but from this, we can project that it might really be this percent or this percent. Is there any way to know that?
I thought at the beginning I knew what you were asking. So let me see if I can, are you saying like, if we catch 51, how many are actually there? Is that the question?
Well, what I'm saying is, you went out with this project and you're sampling certain yards, and you're being able to report back on your sample. But of course, the distribution of the ticks are much wider because you can't sample every yard in the entire area. Is there a way from your studies that you get a feel for maybe what the area is really looking like in totality?
So this data, for example, is averaged over hundreds of sites.
Okay.
So we are getting some kind of distribution,
Okay.
sample distribution. Yeah.
Can you just clarify what you mean by treated?
These are the synthetic bifenthrin treated properties that were treated by Falmouth.
So like if someone wants to do a more natural, like cedar oil type treatment, that does not qualify as treated?
Those data aren't shown here, but we have those data for comparison as well.
Okay.
Yeah. And just a couple more results. So this is another interesting one for us. So we didn't set out to do it. We didn't set out to do a surveillance, but this is sort of surveilling the presence of Lone Star ticks. So these are 2023, 24, and 25. We've seen somewhere in the neighborhood of now 30. Yeah. So about 30 ticks. These are not all individual, not each of those is a single spot, but you can see their amblyomma Lone Star ticks are spread across the Cape. 30 is not a big number. If you go to the vineyard, you'd see 30 is a bad dog walk. You know, like tons of.
Okay, I had a Lone Star 10 days ago.
Yeah.
And I sent it up to US, and luckily it came back negative. But now, does that get reported to any regional things?
It goes in the
database somewhere?
It goes in the database that she was talking about, Lee was talking about before.
Tickreport.com.
Tickreport.com. It's a passive surveillance database.
Okay.
So, Lone Star ticks are widespread on the Cape. We had hoped they'd been on Sandy Neck, so we were catching them on Sandy Neck in 2010, and we were hoping they would sort of stay on the barrier reaches and we could get ahead of it. But seems like they're established a few more sites, a few more places. Not in great numbers yet, but they're here. They're not associated with pathogens to the same extent that black-legged ticks are, but they are associated with a red meat allergy that you've probably heard about, that a number of people are reporting on.
Do you have any data from the Elizabeth Islands?
No. Nashan, Nashawina, Kayam,
They're loaded.
loaded with Lone Star ticks, I imagine.
Absolutely.
So deer are the linchpin here because the Lone Star ticks feed on all three stages.
What about the horses that
Whitetail
don't go? Don't they carry them?
The horses?
Yeah, they bring horses over.
Yeah, I don't know anything about that. I will say also that it's a little bit preliminary, but we see about 25% of those Lone Star ticks on the Cape infected with a bacterium called Borrelia lone stari. So this is in the same genus, the same grouping as Borrelia burgdorferi, the Lyme disease spirochetes. It was long time thought to cause a disease called stari. That break has sort of been made now. And then for some time it was thought not to cause disease, but now people are starting to think again that it does cause disease. So its prevalence in those ticks is a little bit, it's quite high compared to what we've seen before. Whether that's just a sampling effect or whether there's something going on in the Cape that's a little bit different than other places that they've been established is an open question for us. I don't have a slide to show it, but I mentioned like things like this, the surveillance that comes out of this. Remember, as I said, there's no active tick surveillance going on in the state of Massachusetts, anywhere in New England for that matter. And so these kinds of things stand as the record of surveillance. And we found in our collaborator site in the University of Maine, we actually found a novel pathogen that's associated with a Rocky Mountain spotted fever-like illness. So it's being helpful that way that we're discerning these new prevalence of new pathogens or new microbes. So sort of next steps. One thing we did in this last year was we recruited Patrick Roden Reynolds from Martha's Vineyard, Dukes County, and Blake Denias in Plymouth County to do some of the sampling that we do, because it's really hard for us to get down to the Cape. Case in point with my 2-hour drive across the Cape today. So finding local talent to be able to do that, including possibly leaning on homeowners to do some of their own sampling, might be a way to sort of source this project going forward, because it's clear that it's hard for us to do it all on our own. Yeah. So I think that's my last slide. That's me. and my email. That's Melina and her email. And this is Jane, our communications person, and her email. And you can email anyone else if you have questions. Happy to take questions now. If you want to stick around after, I can chat about things. We're very grateful for those of you that are participating in Project Itch. Anyone that wants to sign up, come talk to Melina. And it's my pleasure to be here. Yes.
So, turkeys. The legend, of course, is that, you know, they eat thousands of ticks, etc. But we do have wild turkeys around here. So it had occurred to me that maybe you knew that there had been studies of some sort for anything from peacocks to turkeys that you could keep on your property, including chickens, and whether there was really any data on that. If Zone A was a chicken fence, would that make a difference? Would it be worthwhile trying?
So the Lone Star tick, that one that's newly arrived, that was also known as the turkey tick. So turkeys probably feed as many ticks as feed upon ticks. There's been studies, pretty careful studies by people like Tom Mather, to look at things like guinea fowl. Guinea fowl have been implicated. It's just a numbers game. You just can't, they don't eat enough of them to make a difference. Chickens, guinea fowl, peacocks, turkeys. Yep.
Are the tick tubes that contain the cotton that the mice then take to make nests, are those kind of a relatively simple way to help mitigate the risk on your property? Are you familiar with those?
I am. So simple in terms of application. So if people don't know, it's like
it doesn't harm, numerous other little critters.
Yeah, it's a little more targeted. So the way it works is it's a like a toilet paper towel basically, roll rather. And it's got cotton inside it that's treated with permethrin. And the idea is that the mice go in and they take the permethrin treated cotton, they line their nests, and then it kills the ticks that are nesting. There's a couple of studies that suggest it works. There's a couple more studies that suggest it's not very effective. Seems to be like the makeup of the fauna at an individual site. So the point about chipmunks, if there's more chipmunks don't use them, so it doesn't really affect the chipmunks, the ticks that are on the chipmunks, the numbers they have. So yes, it's an easy way because you go to the hardware store, you buy these things, you put them out in the yard.
But limited success.
Is it effective? Don't know.
Citizen science.
Sorry?
Is there any evidence that certain herbs discourage ticks? And the natural tick sprays, do you have any opinion on how effective they are?
Yeah, so there's evidence that balsam fir, that they repel ticks, maybe even kill ticks under cold temperatures. Our lab's looking at different repellent compounds, things that are derived from plants that seem to be acting as repellents. So remember the difference between an acaricide, which is basically a pesticide of ticks, that kills ticks. Repellents don't kill at all. So DEET, acaridin, effective repellents, they just keep ticks off you. And they probably can be very effective in keeping ticks from doing what they're going to do, which is stay on you for a long period of time.
Can you tell me why, like I tried to look at some of the graph, and yes, there's like this surge from like here to here, but why again in the fall do you see that graph number go up? Like, what is it about that is causing that?
You reminded me that I kept promising to show a figure. So I left out some slides because I was running so late, but I'll show you a slide that shows the
I couldn't figure, is it because the leaves are down, or like what is it that's like doing the spike again?
I might not be answering your question, but let me show you what I was going to show you before. Oh, that one. Oh,
Darn.
yeah, I forgot I have to have internet to show that one.
It should
Free Wi-Fi.
Yeah, Falmouth Public Library has a Wi-Fi if you are able to.
Falmouth guest?
No, starts with Falmouth, so it's in the middle of your choices. There you go.
Sorry about that, but anyway, I got distracted. So you were asking about,
Yeah, I mean, I wasn't understanding the double, like, you know, seems like it's a sizable spike going up in the fall.
Oh,
And
yeah.
I was like, why is that?
oh yeah. So the black-legged ticks have they have 3 stages: larva, nymph, and adult. So the larvae are basically hatched right about this time. They'll start right about this time of year. So August into September, the larvae will be coming out of their eggs. Then they'll take a single blood meal. They'll overwinter, and then in the spring they'll be nymphs. So spring next year, late May, early June. Then those nymphs will molt into adults. Not half, but maybe 40% of them will be active in the fall. 60% of those adults aren't active until the following spring. So those are the 2 peaks that you get. It's 2 different, and for a long time we thought maybe it was 2 different cohorts, like 2 different separate species. They're not, they're the same ones. And what makes them persist, whether they just missed out on the blood meal in the fall and they survived in the spring, is kind of a mystery for us.
Mm.
I can show you that picture that I kept promising to show you, that graph, if you want to see it at the end.
And I will just say, because I can't help myself, again, as an epidemiologist who sees all the data of people getting sick, people do get tick-borne diseases in January, or February, and March here. And so, yes, there are less deer ticks out, but if it's above 40 degrees, you run the risk. They'll be looking for a meal, and those are the adults, and they're the most likely to be infected out of all of them. And so, I say to everyone, tick bite protection is year round on Cape Cod and the islands.
So,
They're not quite as effective because they're bigger, so they tend to get noticed. So
Yeah.
the game with ticks is the small ones.
You
have
don't know
to-
you got bit.
That's
I
right.
didn't know I got bit.
Yeah.
Right.
Okay.
Yeah.
It's easier to notice them, but definitely, like, you can find them.
Do you, just study tick behavior, not tick disease on human behavior? Like when I get bit by a tick, it's like a mosquito bite. It itches and that's how I notice it.
Oh yeah, me too.
So do you know if that,
But that's probably not behavior, that's probably immunity.
Yeah.
You probably have a slight allergy to ticks. I do.
that's what I figured, because it feels like it.
It's a good thing. You have to.
Okay, yeah, that's
Because
my
it
early
itches
morning
just means that
system.
you notice them.
It's a good thing, except then you itch
Yeah.
the week afterwards.
Yeah.
It goes, it itches for 2 or 3 weeks.
Yeah. And you have like a
And you
little
get
lump
bit
there.
again, and it brings up the old issues.